Good afternoon, everyone. Today I am going to talk about multicollinearity in machine learning. I should have learned this before regularization, but better late than never. This video is for people like me, studying data science without a strong maths or technical background. Special thanks to my tutor AJ Sir. Without him I wouldn't have learned any of this. Before multicollinearity, we must understand correlation first. Correlation means the relationship between two variables, x and y. X is the independent variable and y is the dependent variable. Simple example, AJ Sir is x, and I Sparky am y. If AJ Sir teaches me well, I score 95%. Key points to remember. Correlation ranges from -1 to +1. If correlation is +1, it is a perfect positive correlation, both variables increase together. If correlation is -1, it is a perfect negative correlation, one increases, other decreases. If correlation is 0, there is no relationship at all. Strong correlation means values close to +1 or -1. Weak correlation means values close to 0. 1 unit change in x causes a direct percentage change in y. That is what correlation measures. Now let's say instead of one teacher, I have 3 teachers. AJ Sir as x1, Himanshu Sir as x2, and Govind Sir as x3. All 3 are teaching me the same topic, regularization. I score 90%. But now, WHO gets the credit. Was it AJ Sir, Himanshu Sir, Govind Sir? You cannot tell, because all 3 taught the same thing. That situation is called multicollinearity, where 2 or more independent variables are highly correlated with each other, making it impossible to separate their individual effects on y. Here is the 3 teachers analogy explained clearly. If each teacher taught a different subject, AJ Sir taught Python, Himanshu Sir taught SQL, Govind Sir taught machine learning. Then if I scored well, you could clearly give each teacher credit separately. But when all 3 teach the same topic, you cannot separate the individual impact on my score. That is exactly what multicollinearity is. Multicollinearity causes 3 main problems. First, unstable coefficients. In y equals mx plus b, the coefficient m becomes unstable and unreliable because of multicollinearity. Second, high computation. Repeated correlated features increase unnecessary calculation time. Third, overfitting. The model memorizes training data too well and fails on new data. We already learned about overfitting in regularization. Everything connects. We have 3 main methods to detect multicollinearity. First, Heatmap, best for one-to-one relationships. Shows correlation visually using colors. Quick and easy, but avoid cluster map. It has no numbers, so it is hard to interpret precisely. AJ Sir recommends against it. Second, VIF, or variance inflation factor. Most reliable for multiple features. Third, RFE, recursive feature elimination. Like a talent show, rank features and eliminate the weakest ones. VIF stands for variance inflation factor. The formula is VIF equals 1 divided by 1 minus r squared. Important, this r squared is not a power. It is the r squared from the regression model evaluation. To calculate VIF, take x1 as the target variable, use x2, x3, x4 as independent variables, build a regression model and calculate r squared for x1. Repeat for every feature, then apply the VIF formula. Remember, VIF is calculated only for x features, never for y. Now let us talk about VIF score interpretation. VIF can take any value from 1 to infinity. If VIF score equals 1, there is no correlation with other features. This feature is safe, keep it. If VIF score equals 5, there is moderate multicollinearity. Keep this feature but monitor it closely. If VIF score equals 10 or more, there is serious multicollinearity. You must drop this feature. 2 golden rules. Rule 1. Never drop all high VIF features at once. Drop one feature at a time, because dropping one changes the VIF scores of all other features. Rule 2. Always consult the business team before dropping any feature. RFE is like a talent show. All contestants, meaning all features, compete. The judges, meaning the model, score their performance. The lowest scorer gets eliminated. Then repeat until you have your final winners, your best features. The key difference from VIF is that RFE does not depend on VIF scores. It depends on model performance, which features contribute most to prediction accuracy. Both VIF and RFE are computationally expensive for large datasets. That is why for large data, we use Lasso Regularization, L1, which automatically removes unimportant features. There are two types of multicollinearity. Type 1 is data multicollinearity. This is already present in the raw data itself. Example, in any housing dataset, house size and number of rooms are naturally correlated before any processing. Type 2 is structural multicollinearity, created by feature engineering when you create new features from existing ones. Example, distance and time are features. Speed is derived from them. Speed is now highly correlated with both distance and time. You created the multicollinearity yourself. Another example, number of rooms, number of bedrooms, total area, all highly correlated. Just use total area instead. So how do we fix multicollinearity? For small data, use VIF. Calculate for each feature and drop one by one. For medium data, use RFE. Rank features by importance and eliminate the weakest step by step. For large data, use Lasso L1 regularization. It automatically sets unimportant feature coefficients to exactly 0. Fast and efficient. You can also do feature engineering, combine correlated features into one. And always remember the golden rules: drop one feature at a time, consult the business team, and recalculate VIF after each drop. So to summarize what we learned today, correlation means relationship between X and Y, one teacher, one student. Multicollinearity means X variables are correlated with each other, 3 teachers, same topic, can't separate the impact. VIF formula is 1 divided by 1 minus R squared. Score of 1 means safe, 5 means moderate, 10 or more means drop. RFE is the talent show method, rank and eliminate features. Lasso L1 regularization is the best solution for large data, automatic feature selection. And always drop features one by one and consult the business team. Special thanks to AJ Sir.